Alright, so today's lesson is going to be on rational functions. It's going to be about the basics behind what they actually are. So a rational function is defined here as f of x, which is equal to p of x over q of x. And p and q of x are both polynomials. It's really important to make sure that they're both polynomials for this to be considered a rational function. And f of x is defined for any x unless q of x equals 0. That's really important to understand, especially when we start getting into asymptotes. This bottom number cannot be 0 because you cannot divide by 0. It's impossible, it's undefined. So you're not actually able to do that, so f of x will not be defined if q of x is equal to 0. Really important. F of x is equal to 0, this is finding the roots only if p of x is equal to 0 and q of x is not equal to 0. This is important that you check on these problems because sometimes I'm going to throw you tricky ones where the q of x actually is equal to 0 for the root, but that will not actually make sense for the same reason why we said up here f of x is defined only if q of x is not, unless it's q of x is equal to 0. So if q of x was 0 and p of x is 0, that would be 0 divided by 0. You can't do that. And 0 divided by 0 is not 0 in this case, so that it would not actually be a root. Important to understand that. Let me know if you have any questions. It's pretty basic right now for rational functions, but some of the application stuff we're going to use with it is going to be a little bit harder, so I hope that helps.